In today's lesson, we'll be learning how to convert factored form to standard form. In a previous lesson, we learned that a quadratic relation is just a type of pattern, and this pattern can be represented with an equation. You can represent it in factored form or standard form. In factored form, the variable of a tells you the direction of opening, whether the parabola is opening upwards, smiling, or opening downwards, frowning. Meanwhile, the variables of r and s are related to the x-intercept. Remember, you have to change their signs. In standard form, the variable of a again represents the direction of opening. The variable of b doesn't really tell you anything useful about the parabola, and the variable of c tells you the y-intercept. You can convert factored form to standard form using the process of expanding, and you can change standard form back to factored form using factoring. Today we're going to be focusing on expanding. In our first example, we have an equation of a quadratic relation in factored form. We want to convert it to standard form using the process of expanding. We're going to use the table to the right to help us do that. We're going to start with the variable of x, and we're going to write it over here. Next, we're going to take -2, and we're going to write it over here. Next, we're going to take the variable of x, and we're going to write it over here. And last, we're going to take -5, and we're going to write it over here. I'm going to start by multiplying this term with this term and writing the answer in this empty space. Since I'm multiplying two terms, that means I need to use the product rule. And the first step of the product rule is to look at the coefficients. There is no coefficient here, and there is no coefficient here, which just means that there's a hidden 1. We like to multiply coefficients, so 1 multiplied by 1 is going to give you 1. Next, we want to take a look at the bases. The base is x over here, and the base is x over here. Bases stay the same, so this is going to remain x. Last, you want to take a look at exponents. There is no exponent here, and there is no exponent there, which just means there's a hidden 1. And we like to add exponents, so 1 plus 1 is going to give you 2. We're going to repeat this entire process when multiplying this term with this term and writing our answer in this empty box. The first step is to take a look at the coefficients. We already know the coefficient of this term is 1, but what about that term? The coefficient here would be -2. We want to multiply these coefficients. So 1 multiplied by -2 is going to give you -2. We have to look at the bases now. The base of this term is x, but what about that term? There is no base in this term. Bases stay the same, so that variable of x right over here is going to stay the same. So I'm going to write an x right over here. Last, you want to take a look at the exponents. We know the exponent of this term is 1, but what about that term? There is no exponent there since there is no base. Therefore, this exponent of 1 can't be added to anything, so it's going to stay the same. So I'm going to write a 1 right over here. We're going to repeat this entire process again when multiplying this term with this term and writing our answer in this empty box. The first step is to take a look at the coefficients. We know the coefficient of this term is 1, but what about this term? Well, the coefficient here is going to be -5, and we want to multiply coefficients. So -5 multiplied by 1 is going to give you -5. We now need to take a look at the bases. We know the base of this term is x, but what about this term? That term actually doesn't have a base. So bases stay the same. So that is a base of x. We're just going to rewrite it as x down here. And last, we want to take a look at the exponents. We know the exponent of this term is 1, but what about over here? Since there is no base, that means there is no exponent, which means this exponent of 1 has nothing to add to. So that 1 is going to stay the same, and I'm going to just write it over here. I'm going to repeat this process one last time when multiplying this term with this term and writing the answer in this empty box. This should be a little bit more straightforward since you have -5 multiplied by -2. And when you have two negatives multiplying one another, that becomes positive. So this is going to become +10. I'm going to take these 4 terms and I'm going to place them in this bracket. So this is going to be 1x to the power of 2 minus 2x to the power of 1 minus 5x to the power of 1 and positive 10. At this point, you want to identify like terms. These are like terms since they have the same base and the same exponent. When you combine like terms, we're going to get negative 7x to the power of 1. When combining like terms, the base stays the same and the exponents stay the same as well. This 1x to the power of 2 hasn't changed, and this positive 10 hasn't changed as well. Since you have a number in front of a pair of brackets, that means you should be using the distributive property. So everything inside these brackets is going to get multiplied by positive 1. But when you multiply anything by positive 1, it doesn't change. So 1x to the power of 2 stays exactly the same, negative 7x to the power of 1 stays exactly the same, and positive 10 stays exactly the same. I want to clean this up a little bit, so we're going to remove this 1 since we don't like to see coefficients of 1, and I'm going to remove this one as well since we don't like to see exponents of 1. Therefore, we've just converted factored form to standard form.